Thank you, Pooji. Students, यहाँ पे will be talking upon the beats of a sonometer and a tuning fork. It says 5 beats per second are heard when a tuning fork is sounded with a sonometer wire under tension. When the length of wire is either 0.95 or 1 meter, the frequency of fork we need to check. मतलब 5 beats per second 0.95 से भी आता है और 1 meter से भी आता है. That means आप ये कह सकते हैं इन दोनों केस के बीच का डिफरेंस 10 है और ट्यूनिंग फॉर्क इनके बीच की फ्रीक्वेंसी का. सो अगर सोनोमीटर वायर की फर्स्ट फ्रीक्वेंसी देखते हैं अपन तो इट इज 0.95 दैट इज V/2L1 और दिस V/1.9 और सोनोमीटर वायर की सेकंड फ्रीक्वेंसी हियर इट गिव्स V/2L2 व्हिच इज इक्वल्स टू V/2. ये वाली फ्रीक्वेंसी ज्यादा है, ये वाली फ्रीक्वेंसी कम है, तो दिस कैन बी रिटन एज ट्यूनिंग फॉर फ्रीक्वेंसी +5. This should be tuning for frequency -5. If there's 1, there's 2. For frequency you can calculate. This 1 divided by 2 is equals to is NF +5 upon NF -5 is equals to, this will be 20 by 19. So if we simplify this, 19 NF plus 19 into 5, this is 109. 19 into 5 is 95 and this 20 NF minus 100. Simplifying, this is giving us NF is equals to 195 Hertz. Directly we are getting the result. Calculation careful करनी है, approach वही दो equations बनाने की and directly you are getting the result. Thank you, Bhoji. Here we will be talking about beats by an open pipe and a tuning fork. So here it says tuning fork vibrates with the frequency 256 Hertz and give 1 beat per second with the third normal mode of vibrations of an open pipe. So जब हम बात करते हैं open pipe oscillations की, तो fundamental frequency of open pipe is given as this V/2L. It is asking what is the length of pipe, speed of sound in air is given. तो 256 और V/2L का difference यहाँ 1 है, either ways it can be. So in this case we can write V/2L should be equal to either 255 or it is 257. दो possible answers हो सकते हैं. तो V/2L we can write as 255. So here it gives the value of L is equals to V upon 2 into 255 multiplied by 3 because we are talking about the third harmonic. So here we check with the third harmonic. So this can be given as 3 into 340 by 2 into 255. Here it gives 173 से यहाँ कट कर दो, this 85, this comes out to be 2 meter or it is 200 centimeter. And next possibility also you can say this first possibility. So this is the possible answer. And another one you can check with the 3V/2L should be equals to 257. I think now you can solve and calculate and verify what result you are getting. It will be slightly less because frequency we have increased, so length थोड़ा सा कम हो जाएगा, 195 198 के बीच में, something around. You can check and verify. थैंक यू भोजी. रेजोनेंस ट्यूब में एंड करेक्शन एक कॉमन कंसिडरेशन है जो हमेशा दिमाग में रहना चाहिए, और जब भी कभी एंड करेक्शन या ट्यूब डायमीटर या ट्यूब रेडियस की वैल्यू गिवन हो तो हमेशा एंड करेक्शन को कंसिडर करना ही होता है. सिमिलर केस वी आर टेकिंग अप हियर. इट सेज एंड करेक्शन ऑफ अ रेजोनेंस कॉलम इज 1 centimeter. So here we are already given with end correction as 1 centimeter. The shortest length of resonating with the tuning fork is 10 centimeter. So अगर हम एक रेजोनेंस ट्यूब की बात करते हैं तो वाटर लेवल जिस लेवल पे शॉर्टेस्ट रेजोनेट करेगा that will be when the length of tube is equals to λ/4. So if it is L and correction remain constant, so we can write L plus E should be λ/4. यहाँ पे L हमारे पास 10 centimeter given है, E is given to us as 1 centimeter. So you can see the value of lambda we are getting is 11 into 4 is 44 centimeter. This is the wavelength. और अगर हम next resonating length की बात करें तो next resonating length should be what? This should be 3 λ/4. So if I put lambda as 44, it comes out to be 33 centimeter. So this 33 centimeter is including end correction. So हमारी जो ट्यूब लेंथ होगी नेक्स्ट रेजोनेटिंग लेंथ को, अगर हम यहाँ पे ट्यूब लेंथ की बात करें which actually it is asking. So this should be 33 minus E, that is 1, comes out to be 32 centimeter. That's the result of this problem. Thank you, Poji. Here we'll talk upon the case of audible limit on overtones. Situation says a closed organ pipe has a fundamental frequency of 1.5 kilohertz, 1500 hertz दिया हुआ है. It is asking number of overtones that can be distinctly heard by a person with this organ pipe will be, and assume the highest frequency a person can hear is 20,000. इसका मतलब 20,000 से कम की frequency के जितने overtone होंगे those will be heard. So here we can directly write in solution for closed pipe only odd harmonics रेजोनेट, क्योंकि सिर्फ और ऑड हार्मोनिक के ऊपर रेजोनेंस होता है एंड द साउंड इज सस्टेन्ड. सो इन दैट केस वी कैन राइट 2n plus 1 times the fundamental frequency. If we equate it to maximum frequency 20,000 hertz, we'll get the value of n. n वो हाईएस्ट वैल्यू होगी जिसपे फ्रीक्वेंसी 20,000 के आसपास या उससे कम है, क्योंकि ज़्यादा वाली हम नहीं ले सकते. और fundamental frequency is given to us as 1500. So this 2n plus 1 is 20,000 divided by 1500. So this gives us 200 by 15. That will be 150. So 13.33. So here this gives you n is equals to 12.33 by 2 comes out to be 6.12. n अगर 6.12 है इसका मतलब सिक्स्थ ओवरटोन तो यहाँ पे सुनाई देगा. So in that case we can say 2n plus 1 वैल्यू आ रहा है 13.33. So n equals to 6 के corresponding overtone होगा हमारे पास 13, तो 13th overtone हमको सुनाई देगा. तो total number of values of n which are audible, n is equals to 0 to 6. This implies 7 overtones will be heard. That is from 0 के बाद n equal to 0 डालते हैं तो fundamental frequency होती है, that is first harmonic, उसके बाद the second, third, fourth, fifth, तो 7 tones will be heard. That's what we can say. It is asking the number of overtones, so 0 we are going to include, that's also a fundamental tone.